The human body is designed for normal everyday activities, but it is never designed to cope with some of the hazards which we meet in industry on a regular basis. Hazardous materials and small particles that are respirable can bypass the natural defense systems and get deep down into the lung tissues where they can cause serious harm, especially if they are toxic or in large quantities. Our body cannot filter out all the harmful materials, and this is why we need the personal protective equipment such as a respirator. Many particulate respirators use a nonwoven fibrous filter media to capture particles. Fibers from less than a micrometer to 100 micrometer crisscross to form a web of many layers, which is mostly air. It is the spaces between the fibers that allow for breathability. A particle, while trying to navigate through the layers of filter media, gets attached to a fiber due to a number of different mechanisms, such as gravitational settling, inertial impaction, interception, diffusion, and electrostatic deposition. Because of the complex method by which particulate filtration occurs, the smallest particles are not always the most difficult to filter, and most particulate filters have a region of minimum filtration efficiency somewhere between 0.05 to 0.5 micrometer. When the filter media is electrostatically charged, electrostatic attraction can be an extremely effective means of capturing these particles that are most difficult to be captured. A charged particle will be attracted to fiber that has an opposite charge, or a charged fiber will induce an electrical field that will further serve to draw the uncharged particle. 3M disposable respirators are engineered with proprietary advanced electrostatic media. These highly charged microfibers greatly enhance the capture of airborne particles and enable 3M to design respirators with reduced breathing resistance.
This kit is developed to demonstrate filter performance. It visualizes the comparison of different types of filter media. In the middle of the box, there is a generator to pump out airborne dust, which is colored in fluorescent pink. Different types of filters can be installed in each side of the chamber. Fans help move the air through the filters and towards a screen which will catch the pink dust. Now we're going to demonstrate the filter performance with the gauze mask and 3M particulate respirator 8210. The 3M 8210 particulate respirator is in the right side. The other side is holding a gauze mask, which is commonly sold in consumer markets. The fluorescent pink particles, which have distinct color, are added on the scale at the center. Then turn on the fans. The air is moving from the chamber through the fans at both sides. As the air is pumped into the box, the pink particles will soar up and fill the mid-chamber. After a few seconds, we can find the results. Then, we take out the plate from the fan. As you see, the pink particles have penetrated through the gauze mask, but not the 8210 filter. This shows distinctive performance difference of the gauze mask and 3M respirator. Also, gauze masks are not designed to fit tightly to the face, so there may be leakage there too. If a person wore this gauze mask in an environment with these sized particles, the gauze mask might not protect him. From this test, we can find that the importance of the filter media on the respirator so the workers have to select the proper respirator by the airborne hazard types. The fitting of the respirator on the face is also very essential. If you have any questions about the fit test, please contact 3M in your region.